So, hello everybody. My name is Itai. I'm an engineer from Google Tel Aviv offices, and in the next hour or so, I'll discuss the Google Visualization API, specifically the integration with the GWT library, and some other advanced topic as time permits. So the other advanced topic will be latency, a bit some tips and tricks how to improve latency when you use this visualization API. In addition, some tips about security and some things that it might be important to know if you implement data source for this API. And a few words about the data view object that is not widely known as it should be, maybe. Questions at the end. So a few words about the visualization API, just so we start from the same place. This API is a tool of a tool set that's supposed to enable and to make it easy to visualize structured data on the web. It's a JavaScript-based API in its native way, and the main component is a gallery of many visualizations that share the same API. Again, although there are many visualizations and charts, and some of them are Flash-based, some of them are image-based, some of them browser charts, they all share the same API. You just load them from with the Google Loader. I'll show some examples in a second. And after you load them on the same way for no matter what the implementation is, you just create a new JavaScript object, which is the chart that you want to use. In the constructor, you give it a parameter of the div, the web element in which you want it to be displayed. And then you just call the draw function of this chart that accepts two parameters. The first is mandatory, which is the data table that I'll discuss a bit later. It's the same object for all of the same class for all of the visualizations. And the second one is the options that are specific for any type of visualization. Some of the charts have event mechanism for selection events or other events that might be fired from the visualization. And we have like the same model for all of the events from all of the visualizations, so you don't have to learn for each one of them a new different way to handle them. There is another common thing, which is the option to get the data from what we call data source. So you don't have to have all of the data that you want to visualize inside your web page, but you can just have the chart and the options configured in the page, and then you can send a query to get the actual data that you want to present and present it. In addition, third parties can also wrap their charts in this API, and then you can use them also if they're in the gallery. So let's see a few examples before we start. Not here. So this is, in our documentation, this is the gallery of all of the charts. You see there are maps and charts and tables and more stuff. Let's take a quick look about one of the most interesting ones, which is the motion chart. This is a Flash-based chart. Some of you may have seen it. It's used within Google in many places, and through this API, you can see it. You can use it in your site. You can set a chart with 5 dimensions of X, Y, color, size of the bubble, and the time, as you can see here. So this is like a very elegant and very sophisticated chart. Let's take a look on the code that is used on this page. So this is the whole code that you need to do in order to show this chart. What we see here, most of the code is just populating the data, because here it's part of the page. Again, it doesn't have to be this way, but this is just an example. So the first thing we do, we just add a script tag that brings the loader of the JavaScript APIs of Google. It's the same loader for all of them. Then we call a google.load function, specifying the component, the library, in this case visualization library, because there are others, And the specific packages, that here it's only the motion chart, but I could specify as many visualizations as I wanted to on the same load function. Then when the API, when the JavaScript code is loaded to the page, I create a data table. I populate it with data. Maybe the important thing about data table to know is that data table is a two-dimensional table. It has columns and rows. As many columns, it has many rows as you want. But columns has types. So each column you specify, as you can see here on the top of the screen, the type and optionally a label. Type can be string, number, date, datetime, Boolean, and a few more. But it's a set of predefined types that each column and each cell of this column has to be from this type. Rows can be as many of them as you want, and the limit is about the cells. So again, the typing of the cells. So after I just created a data table with all of the data I want to present, I create a chart, a motion chart in this case, place it on a div that I want to, and call the draw function with the data element and some optional parameter. In this case, it's the width and the height that I want to create this chart with. And that's it, and I'm set. So this is the whole code that's actually used for displaying this chart we see here. Just for another example so you can see how it's similar no matter what the chart is, let's look at the area chart. This is a vector graphics-based chart that you can use from the gallery. It's animated. You can click on this, and you can also catch these events, listen for these events, and react when the user clicks, not only the tooltips that are built in. The code, as you can see it here, is much the same. We bring up the loader of the JavaScript APIs. We load, in this case, not the motion chart, but the area chart. We create the data table object. We populate it with data, and we create a new chart and draw it with the data. And here, in addition to the width and height, I also specify that the legend is at the bottom and the title is whatever. But it's quite the same as you saw before. So this is how it works in JavaScript. Now let's see how it's done in Grit. So the first thing you'd like to do if you want to use Grit is to load the wrapping jar, the wrapping library. So all you have to do is to Google for Git Google APIs, and then you get to this page, in which you can find wrapping libraries for each one of the JavaScript APIs that Google provide: search, languages, maps, and so on. One of them is the visualization API. You download the zip to your computer and place the jar somewhere accessible. Then the next thing I did is I created a Git project in Eclipse, just as you saw today in the keynotes. 3 clicks and you're there. And then in order to be able to use visualization from this project, I have to do initially 2 things. The first one, I go to project properties, and I add this jar that I just downloaded to my computer. I add it to the Java build path. Very simple. By the way, all of the instruction and all of the code and all of the example I'm going to show now are part of. You can find them in the documentation of the Git library or of the JavaScript library. Depends on the context. But all of these things are covered in the documentation. So the next thing I have to do is to inherit from Google visualization.visualization. This class is also part of this library of the jar that we downloaded, and then you are set. This is the Git XML file, as you can see there in the project. This is the configuration file of the Git of this project so to tell Git how to work with this. Here you can see this line here is the entry point. This is the class that's going to be loaded and used when this project goes up. So let's see first what it's doing, and then let's have a brief look at the code. So I just started the project. with the the hosted mode. And you can see here a geomap when the values represent the color represent the value. Okay, so you see that the darkest country is Russia here is 700, and Brazil 400, and so on. So this is also a Flash-based geomap, but again, the API is JavaScript natively, and now we're going to see how it's done in Java with GWT. So this class is the entry point class. You saw that we mentioned it in the GWT XML file. And so when everything is loaded, GWT calls the onModule_load function that you can see here, in which we are doing one simple thing in our case that I just want to show this chart. So I call visualization util down here. I call load visualization API, and I specify the callback class to be called when the visualizations are loaded. And I specify a list of visualization. In this case, it's only the geomap. Now, when this is loaded to the browser, the onload callback function class is activated, and the run function specifically. And then let's see what we are doing there. So very similar to the JavaScript, we create a data table. We'll see in a minute how it's done. Then we set up the options that are specific to the geomap. And then we create a new instance of geomap with the data table and options and add it to the panel. And that's it. This is all the code that we have here. Let's see create table, as we said. So it's very, very similar to what we have in JavaScript. We just create a data table object using the create static method. We add rows. We add columns with types and optionally labels, as we see here. We set the values of the cells, depends on the type, and return the data table that we created. This is the first thing. About the option, we saw that we call the create map options. This is the function that is down here. So we just create a geomap options object, and then we can set all of the predefined options. So if I just go to autocomplete here, I can see all of the options, colors, data mode, height, width, and so on. In this case, I left all of the defaults. I only set that the mode is regions. The other option is markers. So you see circles on specific geolocations instead of countries. And this is all you have to do in order to see this example, which is, again, very similar to JavaScript. Now we're going to show you another example that is a bit more complicated. So let's move on and change the class here. That instead of using this entry point, I will use the other one. Not like this. This is all you have to do. The nice thing about GWT is that you don't have to compile anything when you use the hosted mode, as I just did. I have to just save it, go here, and pray. Yeah, okay. So what we have here. Here we have three charts. The first two of them are browser charts using vector graphics. The pie chart, as you can see, it's 3D, and the reason I say it is that I want to show you how I did it in some special way. The other one is just a simple bar chart, but I also used events, so I kind of combine them together. So if I click now on a slice of the pie chart, I made it so the same selection is set on the other chart, as you can see there. If I click on sleep, you see the sleep here too, and so on. Just you can also do this, but it doesn't do anything. But it's nice. Okay. This is why people like this chart. The other chart that you see at the bottom is what we call annotated timeline. You might know it from Google Finance. So it's the general version of the same chart, but it's not for finance. You can use it with your own data. In this case, this is the Terry Gilliam movies, if I'm not wrong. So you can see annotations whenever it makes sense. You can just create the annotation with on your data table, create columns of annotations. It's all described in the documentation of this chart, like which columns means what, and so on. And you can catch events. So when the users select a different range, it doesn't work. I'll try here. Doesn't work. Never mind. So when the user changes the range, okay, you want to show it, right? Okay. So when you change the range, so you see that the event was fired, and I can catch it and alert it or do whatever I want with it. Another interesting thing about this chart here, that the data is not hard-coded in the page as in the example I showed before, so I want to show this as well. So let's take a look at the code. The first thing to notice is that I call the load visualization API, but with 3 packages. The annotated timeline, the pie chart, and the bar chart, just one after the other, using kind of var-arg stuff. You can specify, again, as many of them. You can create them. You can specify in different load functions, but it makes sense to call them all at once. It's just more efficient. Then when they are back, what I do here, I create a pie chart and add a select handler that we'll see in a second. After I add it to the panel, I also create the bar chart with nothing special about it. And I also send a query to the annotated timeline. So when this gets back, I will draw it. So let's see the details. So this is the table that is hard-coded for the first 2 charts. Nothing special to say about it. Let's take a look at the options. So I told you about the 3D. It's not only because I wanted to show that we can set this chart to 3D, but I wanted to show that in some cases, you might find that in the JavaScript API, there are some options that are not wrapped in the GWT library, because the GWT library is always, or almost always, might be a step behind, because we have to add any option. We cannot add them before we add to the JavaScript. So new options have to be added to the JavaScript, and then when they are published, we publish the JavaScript, the Java API, the Java library, and distribute it. So it might take a while until all of the functionality is on the GWT. But if you see that some functionality is not there, you can wrap it on your own, as I show now. So in this case, instead of specifying set 3D equals true, as I could do because it is wrapped, I use the native way, like set option, and is 3D true. And the same thing with colors, as you can see here, to override the default colors. How do I know which options are available? So if we already wrap them, so we can just use autocomplete on Eclipse and see the functions that are available. But if not, you can just go back to the documentation, and for each visualization, you can see configuration options. And here you can see all of the configuration: axis color, the type, if it's a string or object, and so on, a number, all of the options to configure this chart. And this is available in the same format for all of the charts, so you can just go there, find the one that you need, and if it's not wrapped, you can just use the native set option function. So about the select handler, in this function we see how we create a select handler. So this is very simple as define a new select handler. The onSelect function will be called whenever the user selects something on this chart. So notice that not all of the charts have select events. It's also specified in the documentation. But if there are image-based charts, so there is nothing like selection, we cannot let you know if the user cannot interact, in fact, with the chart. But if it's Flash-based or JavaScript-based, then we fire these events. And then what I'm doing here is just I'm setting the bar chart selection to be the same one as of the pie chart selection. As simple as that. And again, you don't have to do this. You could also say, OK, I want to open a new page with this information. The important thing is that you have a JavaScript function that is being called when the user selects something or do any other interactions that this chart support. And in addition to this, you have the data. You know which cell of the underlying data table was called. So it's not only that you get the value. You know the actual cell in the data table, and then you can, if you know that each row represents something, you can go from there to the other cells that means anything and use them in order to do something meaningful. And the last thing I want to show here in this example is the way that I got the data from Google Spreadsheet in order to display the movies of Terry Gilliam. So here I define a data URL, which is Google Spreadsheet, but it can be also a data source that you implement with your data on your site. Tomorrow there is another session about how to implement data sources of this API, but it's fairly easy, and there are already some libraries that do most of the job for you. So in fact, most of the thing that you have to do is to create a data table, as we saw here. All of the other things are taken care of. So you create a query object with the data table, with the data URL of the data source, and you call the send request, the send method, with a callback class that, as we see here, inline, I created the onResponse. I implemented the onResponse function. This function is called when the response gets back from the data source with the actual data that we want to present. If everything goes well, I can just call response get data table, and I get the data. And from here, it doesn't matter that I got the data from anywhere remote and didn't create it in the locally on the browser. In addition, I already also added here the event, the range change handler. So whenever the user changed the range selection, I can do anything I want. In this case, I just alerted, but of course, this is not the thing that you'd like to do. So that's about it about the GWT integration. You can also wrap your own visualization or wrap unwrapped methods and events. The library is open source. So if you see that something is missing, not only that you can maybe contribute to it, but also you can just take a look and copy the code and locally create the thing that you miss. So again, just to wrap it up, using a visualization is as simple as create a new chart, create a data table and options. Creating a data table is just by creating a data table, add columns and rows, set the values. Configurations can be set using the options object. Data can be requested from a remote data source using the query object. Event, most of them are already wrapped, so you just add event handler and do whatever you want when it's fired. Unwrapped options can be used with the set option function. And that's it about the GWT integration. Some other topics now. Let's start with latency. It's a good time to. So as we just saw, before any chart can be displayed, there are some things that have to happen before. The first thing that it has to be loaded. If it's sometimes it's just the main library that includes the data table and the query and the core library. But if it's some sophisticated visualization, like the motion chart that we saw, or any other flash-based, so all of the resources have to be loaded all the same. After everything is loaded, you create a data table, and you populate it with data. This means that you might need to call a remote data source, but sometimes you just want to create it locally on the browser, or maybe to generate it dynamically, but when you generate the page. So it's not using a data source. It's something that happens on your page when the page is rendered. And only then you can draw the chart. And the first two steps can be sped up. So let's see how it's done. The first thing we saw that there is a single way to load the visualization and all of the other APIs, actually. So if you're using this step is correct also for other APIs that you might use, you might wrap in Grid. Not in Grid, sorry. So you might use in Google. So the first thing, you just call a script of the JS API loader. And then when you have this script in your browser, you can call the google.load with the parameters of the library that you want, the version, and all of the packages. The result of this process is 3 HTTP requests, 3 round trips. The first one to bring the JS API loader itself, which is a very light one, but still a round trip. Then another 2 from the google.load. The first one is to get the current version of the hashed URL of the current version of all of the libraries that you want. And the second one that can be cached by the browser is to actually get all of the JavaScript bits. Again, the result of this is 3 round trips. So there is another new feature of this loader that you can read the details in the documentation that lets you skip the second one, which is a very light one, but still another round trip that cannot be cached in the browser, and it saves a few milliseconds. Might be important if you have, I don't know, many pages or many users. Latency is important. This is one lesson that we know in Google. So as you can see here, you just add to the JS API script another parameter in the JSON format of auto-load, and then all of the modules and the packages that you want to load into this page. And this will save you one call. The disadvantage of this approach is that you have to really type all of this JSON, and usually you spend more time on setting it up than the latency of all of the users that will see this page ever. So one nice tool that there is now, you'll find it in documentation, there is a UI. So you can just specify all of the features, all of the libraries, and all of the packages that you want to include. And then the result is this line that you see here. You just copy-paste into your page, and then you save all of these mistakes. And this is a way we can save, I don't know, dozens to hundreds of milliseconds. Depends on your internet connection and your user's internet connection, in fact. Another thing is how you create a data table. So we said that one option is to go to a remote data source, and I'll expand in a few minutes about it. But let's say that you create it locally on the browser. So in this case, there are 2 ways to do it. The first one is what we saw in the example so far. You just create a new data table and populate it with data. Add columns, add rows, and set the cell values. If you have a very small and static data, then fine, it doesn't take time. But if you have hundreds or thousands of lines of data, of rows of data, and more than a few columns, the browser needs to process all of these functions, and it takes time. Although JavaScript is much faster than it used to be, it still takes time. There is an alternative, which is using a JSON object. The result is about double or half of the latency that it takes to create a data table. The bigger the data table is, the impact is bigger, of course. And you just create a data table with the JSON object in a single command, and then everything will happen behind the scenes, and you get a data table with all of these features. The notation, the exact details, I will not get into it now, are just the same. So described in the documentation, and you can get the same result. So everything that you can do with the data table set column or set cell, you can do with this JSON notation. So it's just a matter of programming and if you have a server that generates this code anyway, so once you want to, maybe one time you want to sit down and do something that generates this JSON instead of generating calls to add cell, and so on. And these are the 2 tips about latency. Security now, or more correctly, privacy. So I already mentioned that there is something called data source. In most of the cases, when you have dynamic data or you have a large data, you don't want to have it as part of your page. You don't want the page to be rendered with all of this data. You want the page to be rendered only with the titles and the interesting stuff in it. And if you have a chart, you want only to load to hard code the chart, the options, and write a line that's saying query send. Get the data from some remote URL and present it, which is nice, but there is a problem. The question is, if you can get to this URL to get the data, so maybe some other people can also do it. And until now, we used some technique called script injection to get the data. This technique enables access from what's called cross-site access. So you can get the data from other domains than yours. Why is it good for? It's good for a few cases. One of them is gadgets. Gadgets always rendered in what's called subdomains. They're always in an iframe served from different domains than your page. It means that if it was only possible to get data from your domain, you will not be able to use gadgets. And another good reason that we use this technique is because Google Spreadsheet is a very, very good data source, a very used data source. So people mostly keep data in Google Spreadsheet and then access from their web page to get this data on the page. So again, this is not the same domain. Normal HTTP GET requests, the browser do not send them if they are to a different domain. But again, the problem is that if you can get this data from different domain, then maybe someone else can do it. There are known techniques and known ways to prevent this. But this is something that you should be aware if you're using data sources of your data. And of course, if this is a public data, then there is no issue, of course, no issue at all. So we have just introduced in the latest version of the JavaScript and the protocol that we announced a few days ago, a new mode that we call restricted mode. This lets you use, in this case, what we are doing is the request from the JavaScript library is sent by XHR. So it's only for the same domain. You should use this mode if you have a data source and you have your web page and they're served from the same domain, and you want to make sure that nobody from any other domain, gadget or whatever it is, can access this data. So in this case, you will use in the request, you'll specify that you want the request to go in XHR mode, in Ajax. The browser will let it go because it's on the same domain. But the most important thing is that when the library, the JavaScript client, will send this request, it will add some header, some custom header on this request. And this custom header is something that, together with cookie authentication that you anyway need to do if you want to make sure that only validated users, only authenticated users can see this data. So there is no way that hackers can send requests from a different site to your site and still have all of these cookies and this header. No way. So on the server side, on the data source, all you have to do is to make sure that there is this, if you want this data source to support only your domain, all you have to do is to make sure that the user is authenticated and that the header, the custom header, is there, and you are set. You know that the request came from the same domain, and you can return the response to the client. In the new JavaScript, Java library that is open source, and when it was announced a few days ago, and I'll discuss in a different session tomorrow, this is already implemented. So if you're using this one, you don't have to do too much. But even if you do it on yourself and in any other language or application, you can just take a look and see how it's done. It's documented, and it's very simple and reliable. In the client side, by the way, the way to decide if you want the request to be an XHR or script injection. It's just another new parameter. If you don't specify this parameter, as it was the case for any code that was written until a few days ago, so we just automatically decide if it's to the same domain, we send the request as XHR, and we add this custom parameter. But if the request was for a different domain, we just use script injection, so the browser will not prevent it. This is not a security risk here, because anyway, in your data source, this is the place that you have to make sure if you want to prevent requests from different domains. Another thing that I'll cover just in a few words. There is some tool of Google called Google Secure Data Connector, SDC. You can find documentation about it. It's kind of the thing is that it lets Google services like App Engine or Google Spreadsheets or gadgets at Google sites to access data that is behind your VPN. So, of course, it doesn't happen as is, like magic. You have to install some client, which is an open source, some agent software that is an open source in your firewall, and to describe exactly. Sorry. You have to describe exactly the resources and the user that you want to be able to access these resources behind your firewall. But once you've done this, so Google Spreadsheet and App Engine and sites can access this data and present it. So since there are gadgets that wrap all of these visualizations that we saw, we have, in addition to this gallery of visualizations, there is another gallery of gadgets that are generic gadgets that wrap any one of these visualizations. You can also write your own custom gadget if you want to specify some different options than the default ones that we set. But the nice thing is that when you use gadgets, you can let the user specify the options, with the UI of gadget prefs, and specify the data source URL and everything. So the nice thing here is that the client library is already supporting this, the way that a request sent to this SDC stuff. And all that you have to do is to add TQRT, which stands for table query, which are all of the parameters of this API. Request type equals make request. Make request is a technique that's used by Google Gadgets to get data, and then the request is not sent from the browser itself, but through the container, the server that serves this gadget, with all of the security validation and everything, and is sent through the VPN, through this SDC to your data. So it's safe. The only thing to make sure that, of course, that the configuration of this agent. And last word about security. So data policies. Most of the visualizations do not send any data outside of your browsers. This includes the interactive charts, the JavaScript one that we saw, or the Flash ones. So how it happens, you load the visualization engine from the web, from Google. You bring the data table from the page or from your data source, and then you call the draw function, and the chart is rendered on your browser. But in some cases, the data is sent to different servers. For example, the image-based charts of Google using the Google Charts API, in case you know it, and these are charts that are rendered by URL. You specify in the URL all of the parameters. I want a pie chart, and the legend should be this, and the data is that and that. And all of this URL is sent to Google servers, is not kept there, but is sent outside of your browser and get back to you. And the same goes for third-party charts. Some of them send the data to their server in order to do some pivoting and sophisticated stuff. So this is something to be able to know, okay? The risk is something that you have to decide. How can you tell? So you go to the visualization gallery that we saw before. You just select any one of the charts, say the motion chart, and the last item here is, not the last, one of the last, is data policy. You just go there and see if it sends data outside of the browser or not. That's it. Again. And the last thing I'm going to cover in this session is data view. So the ones that are familiar with SQL know the concept of data view, of view in SQL. And in this API, we have something very similar. So far, I all the time said you create a data table and you pass it to the chart. We bring a data table from from a remote data source, or you bring it, you build it locally. But this is data table. There is another object called data view. You can pass it, as we see in the last line here, to the draw function of each visualization. And for them, it's just the same. They don't know that this is a data view, not a data table. The difference is that you build it on top of a data table. And the data is not replicated. It's kind of a window, okay, or a view over a data table. You specify the columns that you want to include in this view, and you pass it to the chart, and it's kind of an indirection, okay? So the chart thinks that these are the columns that are in the table. It doesn't know that in the underlying real table there are more columns. What is it good for? We said that all of the charts using the same data table concept, which is true, but each one of them expects different columns. For example, a pie chart would expect always two columns. The first one to be string, which are the labels, and the second one to be the actual values that the slice takes. But there are other visualizations. For example, the table visualization, that is a very nice table that you can select cells and rows and you can sort and everything. But for the table, we don't care about the column formats. There can be as many columns as you want, and they can be from any type. We know how to show them. We don't care. So what happens, let's say that you have a page, and you have two charts that you want to show. You want to show a table, visualization, and a pie chart. The pie chart is only two columns from the one that you want to show in the table. If there was no data view, you had to do one of two things. You had to, or that you send two queries and build two data tables on the first place, which takes more time and more storage on your browser. Or you could maybe create a data table and then replicate it and remove some rows or some columns and so on. Using this data view, you can just create a data view, specify the right tables, the right columns, and maybe you need to change the order of these columns, and then you are set. Let's see a good example. Again. So this is, by the way, a very nice tool that is, you know it, some of you, maybe? It's called the Ajax API Playground. It has examples and codes that you can play with for all of the Ajax APIs, again, search, maps, visualizations, languages, and so on. And you can actually take the code, you see the code, you can play with it, run the new code now, and you can save local copies under your profile. Very nice tool. I use it all the time. So in this example, what we see is we create a data table up here. We populate it with data, and then we draw, which the result is this original data table. Okay, this is a table visualization. I can sort it. I can select rows. This is a very useful table. But the fact is that it has 4 columns. And I want to have another chart here with only the age and the names of the people here. So I need to take only the first 2 columns. And in this case, you can see here, I create a data view with columns 0 and 1, which are 1 and 2, as you know. We all like it. And just pass this data view as the first parameter to the draw function. In addition to this, you can also filter the rows, not only the columns. You can set the rows, the row indexes of the underlying data table that will be used in this view. So you can do the same trick not only for columns, but rows based on their value. So as you can see here, there is a function on data table called getFilterRows. The return type of this is an array of indexes, not the actual rows, but the indexes of the rows. And you can specify as many filters as you want in combination. You can specify column 2 value equals 42, like here. You can specify min and max values instead of a single value. And you can create multiple of these. As you can see, it's an array. So you can say column 2 value 42, column 3 min, max, and so on. Then you get the filter rows. You can also sort them by get sorted rows, which is another function of data table, and then set rows on data table. And only these rows will be on the data view. And then you'll have only these rows and only these columns that you want, and you can use them in any chart that is using data table can use this data view now. You already saw the example? And that's it. Again, tomorrow there is another session about this visualization API, which is specifically about data sources and the new Java library that was released as open source a few days ago, with the include query language implementation and many other features. That's it. If you have any questions, this is the time. Thank you.
Hi. Most JavaScript libraries, you can just take them and embed them in your application server and serve them. Why does the visualization API require you to talk to the Google? Why is it hosted with Google? Is there a way that we can host it ourselves?
I'm not sure I got the question.
So you have the URL google.com/JSAPI.
Okay. So the question is, why do you have to load the visualization and the code every time from Google?
Yeah.
And not host it in your application.
Right.
So the fact is that in this way we can ensure that you use the latest version of the charts and everything, and otherwise we'll get into troubles of maintain version and people will use older version, and then we have to support them, and when we go and use the next version of some other feature, it will not work together. So this is how we decided to do it. I see the disadvantage, but since most of our users are web-based, we don't see the big problem.
Is there any way to get around it at all, or is that totally not allowed? Because we really don't want to host it with Google.
So this is the way to use it. You have to be online in order to use this library.
I see. So I had one more question, and that is the visualization engine. What we found was that each time you load a visualization engine, such as pie chart or line chart, the performance degrades depending on the number of visualizations you want to load. Is that true? Is that some way we can get around it? Because you might have 20 visualizations that your application might use, but at any given time it just might use 2.
So there is a way to not to load all of the visualization at the first time. You can read more in the documentation, but you can. So all of the examples I showed here were using the onload callback. So you just specify on the first time when the page is loaded, you say, okay, I want to load this visualization. You load them, and when you get them, you start working. You can also load them what's called lazy loading.
Yeah.
Okay. There is an option to do it. You can read it in the documentation. It's very simple. All you have to do is to specify a callback function that will be called when they come back.
Yeah, so
you don't use the onload callback.
The problem is if I load 2 visualizations lazily, the total time of load is less than if I load them together. So if I load them together, if I just say, load pie chart and line chart, and I get one callback, it's faster. But if I load them asynchronously, it's slower. So I pay a penalty whichever direction.
So I'm not. There are only 2 ways you can do it. So either you load all of them together and wait, to get all of them, or any time that you need any one of them, you load it. I just can't think of any other way, but we can discuss it later if you have any ideas. So
okay,
thank you.
I think last year you said that there would be some way in the future to access other data besides spreadsheets. Like, is there any progress being made to being able to use data sources other than Google Spreadsheets?
So today there are no public data sources outside of Google Spreadsheets. There are many data sources that are private of users. For example, in Google, there are like dozens of projects that use this API internally and provide a data source for their pages, but they are not public. In addition, there are libraries. You can find them in the documentation under some tools gallery of libraries that implement the data source. So you can just download them. There is one in Python of Google, another one in Java of Google, and there are many other open source and so on. So you can just download and create your own data source. I'm not aware of any other like public data source. There are some interesting charts like chartle.net that provide an interface that you can just load the data to and create kind of a wizard to create visualization and share them with others. But there are no tools like Google Spreadsheet or data sources.
In my application, I have to create and delete a lot of charts dynamically. And when I do it, after destroying, charts left some data in browser. Memory is leaking. What is the true way to destroy charts?
No, I'm not sure that I got you. Could you repeat?
Okay. If I create chart and delete it dynamically, this chart left some data in JavaScript.
Okay.
How I should destroy charts correctly, not to call memory leaks?
So generally speaking, there is a Java collector mechanism in JavaScript, and if you create charts and you delete, if you delete the object, it should release the storage.
Yes, but Google visualization charts create some attributes on Windows level.
On what?
On window level. Window document object model.
Okay,
model.
So this is something, if you have any specific question, I can check them. Generally speaking, we try to avoid this, of course, and we try to release everything, so if you just delete the chart, then everything should be deleted.
But the same thing with any kind of chart that I try to use, actually.
Okay, so again, I never heard this complaint, and I'll be happy to see it, and of course you can send to there is the user groups on the documentation, so you can just send it to there.
Okay, thank you.
Okay.
Hi, I'm not quite sure I understand when you mentioned about Google visualization chart solution to prevent the cross-site SQL injection. You said there is a customized header to the HTTP package called XHS. So in other words, this is not a standard implementation of HTTP protocol. So I don't understand the detail. That's why I'm asking. That's why we have to talk to the Google server to.
No, it's totally unrelated to the question before that. Why the visualization go to the Google server? You have to load them from the Google server, even if you don't have any data source. Even if you're just using creating your JavaScript on your page and don't go to any data source to get the data from. This is from questions that nothing to do with security. It's about versioning, and it's about serving, being able to serve. It's correct to all of the Google Ajax APIs, not to this visualization.
Oh, okay.
The thing about the custom header, which again I'm going to cover tomorrow about the data source implementations, is a known way to ensure that a request comes from your domain and not from different domains. Some people use refer and some other techniques that are not that strict as custom header. So, in other words, if your users use normal browsers or good browsers, any browser that you know of, so there is no way that hackers can get from another site and send a request to your site having this custom set and your cookies, the cookies of your users from your site together. If there is, without this custom header, it can be done in some way. It's not that simple, but it can be done. And even refer is something that good hackers can manage and find out how to set. But there is no known way in normal browsers to get all of this information and the custom header and the cookies from a different site. So it's safe.
So this is not a topic related to Google visualization package, right? Is some other? I guess my question is, SHS is that a standard HTTP protocol part of the protocol itself, or is it something new added by?
It's nothing new. Custom headers headers is something that is part of the HTTP specification.
Okay.
So it's nothing that we just use a quite known technique to help you make sure that the request is from your site. That's all.
Very well. Thank you.
Okay.
Just quickly, are there any limits on how much data you can cram into the visualization API? Like, how many?
There is no strict limit. The limit is, browsers and JavaScript is so.
Tens of thousands or thousands? Can you get?
I guess. So let's put it in other words. It doesn't make sense to send million rows to your browser in order to visualize them, right? You should group them or filter them or do something on the server side. If it's about 1,000, it should work. If it's a few thousand, it should work. If you try to use above, I guess, 10,000, just let's say, then it will take time, latency of the network until you get the data. It will take time for the browser to process it. And usually it means that, I don't know, I think most of the users cannot really understand a chart that contains 1,000 or 10,000 of data.
Okay, thank you.
All right? And last one, okay, and after that, just come here if you want to discuss.
For the annotated timeline, right now you only have a choice between line or area chart type. Is there any plans to add bar or any other chart type?
To do what?
For the annotated timeline, there's only a line chart type and area chart type right now. Is there any plans to add bar chart to?
Not in the near future, but what you might find interesting is that in the motion chart that I show with the bubbles, the moving bubble, there is a way to create a bar chart there, if you saw it. There is, on the top right corner, there is bar icon, and then you can use this bar. This, which is a very, very nice chart, so you can use bar chart there. Not in the one that you asked about.
Is there any plans to extend some of the chart visualization, or like add more features, or?
We constantly add new features. If you can take a look at the documentation of the last one, we just added more options to the table and to this chart even.
And for the table, is there any plans to add column reorder?
To add what?
Column reorder. Reordering the columns in the table?
Not in the very near future. After that, I'm not sure.
Okay. Thank you.
Okay. Thank you. Hi. Just a second. Well, just a second. I'm trying to do something which I really don't understand.